The morning of May 30th, 1942, found London wrapped in that particular grey light that seems to hang over Whitehall even on promising days. Deep within the corridors of the British War Office, in a conference room where military decisions shaped the course of nations, Admiral Louis Mountbatten stood before an assembly of senior commanders and military strategists. The tension in that room was palpable, the weight of war pressing down on every shoulder. He spoke his words deliberately, letting them fall into the heavy silence. If we cannot locate suitable ports, we may need to construct them from components and bring them across the water. The response came swift and cutting, laughter that filled the room like a sudden wind. Officers with decades of experience in naval tactics and military construction erupted in derision. The hoots of amusement, the jeering comments, they reflected the absolute certainty these men possessed about the boundaries of what could be done. The notion flew in the face of everything they understood, about how harbors functioned, about the principles that governed them, about the physical laws that made such a thing impossible in the Channel's treacherous waters. To construct an entire harbor from scratch, to somehow transport it piece by piece across one of Europe's most dangerous stretches of sea, to assemble it under relentless enemy bombardment in a matter of days. It seemed the fantasy of a desperate mind. And yet, in that moment of ridicule and dismissal, something extraordinary was being born. In the mocking laughter echoed the first stirrings of what would become the war's most stunning engineering accomplishment. A venture so breathtakingly ambitious that it would fundamentally alter how amphibious warfare could be waged, shattering assumptions that had crystallized in the German command structure. The underpinnings of what would make D-Day possible were not going to be constructed entirely through battle tactics and military maneuvers alone. They would be built from concrete poured into specific shapes, from steel girders and fabricated sections, from hydraulic mechanisms and complex calculations involving tides, from the radically new proposition that even impossibility was simply an engineering challenge waiting to be solved. Yet first, there came a tragedy that would make the urgency of this vision undeniable. The catastrophe unfolded on August 19, 1942, when the beaches of Dieppe became a furnace of violence. Operation Jubilee, as it was named, was meant to test German defenses and show the enemy that the Allies possessed both courage and capability. Over 6,000 Allied soldiers, the majority of them Canadian, launched themselves at the shoreline. But waiting for them in carefully prepared positions, concrete bunkers dug into the white chalk cliffs that dominated the beach, were German gunners with machine guns trained across the killing ground below. Wave after wave advanced into that murderous fire. The men fell, cut down before they could reach the seawall. 27 Churchill tanks, those massive steel hulks that troops counted on for support, roared onto the shingle beach to meet the same fate, destroyed, abandoned, or captured by German forces that controlled the high ground. In less than 9 hours from the first man touching shore to the final boats pulling back to sea, the operation left behind a trail of blood and broken bodies. Of the 4,963 Canadian soldiers who crossed the Channel that morning, fewer than 2,000 made it back to England. Many who returned carried wounds that would mark them for life. The count that emerged from those hours of slaughter shook military planners to their core. Canadian losses totaled 3,367, with 916 young men dead and nearly 2,000 taken prisoner. The Royal Navy paid in blood as well, 75 killed, 269 missing or captured. Above the water, in the skies where Spitfires and other fighters battled the Luftwaffe, 62 men from the Royal Air Force gave their lives. The German garrison barely suffered 600 casualties. In those 9 hours, a devastating lesson was written in blood across the beach sand. The Allies could not take Europe without a major port to funnel supplies and equipment ashore. Yet Dieppe demonstrated with cruel finality that assaulting any fortified harbor would be nothing short of mass suicide. The German defenses were simply too formidable. General John Hamilton Roberts, the officer commanding the Canadian division, would document what he had learned in his official report, a document later discovered in the National Archives containing observations that cut to the heart of the problem. The strength of German port fortifications went far beyond what intelligence had predicted. Massive concrete structures housing heavy artillery could withstand naval gunfire, Interlocking fields of machine gun fire had been calculated to cover every possible approach. The port structures themselves had been rigged and prepared for complete destruction the instant enemy forces approached. Even if, against all odds, the Allies somehow managed to capture Dieppe intact, German reinforcements would have reclaimed it within 2 days. The strategic contradiction was now obvious and unyielding. To invade continental Europe successfully, the Allies needed a port. The Germans, however, had lined the entire coastline, from the Norwegian frontier down to Spanish territory, with millions of tons of concrete and steel. When Erwin Rommel arrived in late 1943 as Inspector General of the Atlantic Wall, Hitler's boastful slogan suddenly became a genuine, formidable obstacle to invasion. By the year's end, Rommel had completed his comprehensive tour of Atlantic defenses. His classified evaluation, archived in German military records, revealed the depth of his concerns. No unified defensive strategy existed across the entirety of the coast, and whatever preparations had been made seemed inadequate against what appeared to be an imminent major assault from across the Channel. Rommel's response was pure Rommel, aggressive and uncompromising. He ordered millions of mines distributed along beaches where invasion might occur. Concrete pillboxes rose at every critical location. He personally oversaw the construction of beach obstacles crafted specifically to tear open the hulls of approaching landing craft. His infamous asparagus, wooden poles sharpened to lethal points, was planted in fields behind the beaches to impale descending gliders and paratroopers. But Rommel's most critical efforts focused on strengthening the ports themselves. In a classified memorandum sent to Hitler on the last day of 1943, Rommel laid out his strategic assessment. The enemy's landing operation would likely target the 15th Army's sector, he wrote. The enemy's paramount objective, in all probability, will be to obtain rapid possession of one or more ports capable of accommodating major vessels. Hitler responded by designating 11 major harbors as Festungen, fortresses to be held at all costs, to the final soldier. Dunkirk, Boulogne, Le Havre, Cherbourg, Saint-Malo, Brest, Lorient, Saint-Nazaire, the Gironde River estuary providing access to Bordeaux, and the Channel Islands all received reinforcements, men, material, and armament. Each fortress boasted heavy naval artillery mounted in reinforced concrete casemates, batteries of field guns positioned to rake every conceivable landing approach, anti-aircraft installations, extensive minefields spreading miles into the hinterland, and garrisons sworn to fight until death came. This was the foundation of German military planning, an assumption so deeply embedded that commanders did not even question it. The axiom held that any invasion required the seizure of a major port within the opening days of the operation, or the invasion would collapse from want of supplies. This principle had governed military campaigns since ancient Rome. Armies needed harbors where supply ships could dock. They needed shipyards for repairs. They required cranes and equipment for loading and unloading. They depended on warehouses and protected storage. And they needed shelter from the violent storms that could destroy an entire fleet in hours. Dwight D. Eisenhower, recently appointed as Supreme Commander of the Allied Expeditionary Force, confronted this dilemma with clear-eyed realism. In a personal journal entry from March 1943, he captured the impossible choice that seemed to mock every option available. "The situation presents us with a dilemma that admits of no favorable resolution," he wrote. "We can assault a heavily defended port and accept tremendous losses in the attack itself, or we can land on undefended beaches and watch our supplies dwindle to nothing in a matter of weeks. Both paths lead only to failure. Only one possibility offers any glimmer of hope, though it contradicts all established military understanding. That possibility, which Eisenhower had begun to consider, traced its conceptual roots back through the decades. The seed had been planted long before this moment, during the First World War. In 1917, Winston Churchill, then serving as First Lord of the Admiralty, had proposed an audacious scheme, using flat-bottomed barges and fabricated concrete structures to create an artificial harbour in support of planned operations against the Dutch coastal islands. The Great War concluded before the concept could be tested in actual combat. Yet Churchill retained the idea, carrying it forward through the years. When spring of 1942 arrived, Churchill found himself in a conference room, wrestling with the same question that now tormented Eisenhower. If ports could not be captured, what then? His response, remembered vividly by those present, electrified the gathering. If we are unable to seize a port, we will manufacture one and transport it across the water with our fleet. The statement hung in the air like a revolutionary proposition. The engineering obstacles seemed astronomical. How does one construct a harbor that can accommodate hundreds of cargo vessels? How is thousands of tons of concrete and steel transported across open ocean? How is such a structure assembled amid enemy artillery fire? How is it anchored to the seabed when tides rise and fall by more than 20 feet twice daily? How is it protected from the violent Atlantic storms that frequently swept the channel? Each question opened into further complexity. Yet strategic necessity permitted no other path. On May 30, 1942, Churchill issued his directive to Admiral Mountbatten. The order, preserved in War Office records, contained just 60 words that would reshape military history. Piers for use on beaches, they must float up and down with the tides. The anchor problem must be solved. Provide me with the best possible solution. Do not debate the matter. The obstacles will make themselves evident. Mountbatten assembled Britain's finest talents: engineers, naval architects, construction specialists. Initial meetings at the Institution of Civil Engineers on Great George Street in Westminster generated far more questions than solutions. The scope of what Churchill demanded seemed to contradict the laws of physics and basic engineering sense. The calculation came from Lieutenant General Frederick Morgan, Chief of Staff to the Supreme Allied Commander, whose planning organization, known by the acronym COSAC, determined what would be required. The artificial harbors would need to match the capacity of Dover, England's primary cross-channel port. They would handle 12,000 tons of cargo daily, in any weather condition. They would accommodate everything from small landing craft to 10,000-ton Liberty ships. They would furnish protection for vessels in seas reaching Force 6 conditions on the Beaufort scale. They would need to be fully assembled and operational within days of the initial landing. The requirements alone generated hundreds of pages of dense technical specifications. Engineer Hugh Lewis Hughes, a Welsh specialist in harbour construction with decades of experience, drafted detailed plans for a floating harbour between June and August of 1942. His designs incorporated lessons from every significant harbour project of the previous 100 years. Other specialists contributed their own innovations. Royal Engineer Lieutenant Alan Beckett developed flexible steel roadways capable of rising and falling with the tidal cycle while maintaining constant connection to the shoreline. Naval architects proposed sinking obsolete merchant vessels in calculated positions to serve as instant breakwaters. The most spectacular component would be enormous concrete structures, floating chambers that could be towed across the channel and positioned to form protective barriers. October 1942 brought a combined operations conference at Largs in Scotland, coded Operation Rattle. There, Commodore John Hughes Hallett and Royal Navy Captain Tom Hussey presented the complete scheme to assembled commanders and planners. The presentation consumed 4 hours, covering everything from precise tidal calculations to the chemistry of concrete formulation. The initial response dripped with skepticism. American officers in particular voiced substantial doubts. One American naval captain, recorded in the conference minutes only as Captain S., summarized the consensus objection. You are proposing to disassemble the equivalent of Dover Harbor into thousands of components. Ship those components across the world's most treacherous waterway, reassemble them beneath German artillery fire, and have the entire facility operational within 7 days. I have served in the Navy for 2.5 decades, and I have never encountered a scheme more patently absurd. Hughes Hallett's answer, captured in the official transcript, revealed the desperation underlying Allied planning. Captain, you are entirely correct, he replied. This scheme is absurd. It violates fundamental principles of harbor engineering. It demands technical innovations that presently do not exist. It calls for industrial production that may exceed our total capacity. Nevertheless, I must ask you to examine the alternative. Either we solve these absurd problems, or we abandon any aspiration to invade Europe. The choice is genuinely that stark. A simple demonstration gradually shifted the atmosphere in the room. Commander Robert Grant conducted an improvised experiment using the conference sink, miniature paper vessels, and a hairbrush. He first set the paper fleet in the water and began vigorously brushing the surface to create waves. The tiny ships capsized immediately, spinning helplessly in the artificial storm. Then Grant secured a Mae West life jacket in the sink, positioning it to represent a breakwater, and placed the paper fleet inside its protection. He brushed the water again with equal vigor. This time, despite the waves breaking against the flotation device, the paper ships remained upright and afloat. The demonstration was elementary, almost childlike, yet it illustrated a principle both fundamental and profound. Water under protection meant vessels that survived. Vessels that survived meant supplies that reached shore. Supplies reaching shore meant the possibility of victory. The concept received consideration at the Quebec Conference in August 1943, where Churchill and President Roosevelt gathered with the combined chiefs of staff. Churchill presented the artificial harbour proposal with the eloquence he commanded so naturally. His opening remarks, captured in the official conference record, conveyed the sheer ambition of the undertaking. "We propose to execute the greatest construction enterprise in military history," he stated, "and we will accomplish it in absolute secrecy, at tremendous speed, under perpetual threat of enemy discovery. We will construct 2 complete harbours, convey them across the Channel, and assemble them on contested shores. The Germans cannot conceive of such an accomplishment. Their inability to conceive it will be our greatest advantage." Roosevelt grasped the implications immediately. His personal background in naval affairs, dating to his service as Assistant Secretary of the Navy during the First World War, gave him genuine understanding of the technical obstacles. Yet he also comprehended the strategic imperative driving the enterprise. The senior military leaders huddled together for 2 full days, going through every detail methodically. They scrutinized everything: the strength of the concrete structures, when the tides would be highest and lowest, how far German guns could reach from the shore. After exhaustive examination on September 2, 1943, they finally reached their decision. The military planners calculated that these man-made harbours would need to process 12,000 tons of supplies each day, not counting vehicles, and they had to work no matter what the weather threw at them. 4 days later, on September 4th, the order came down to move forward immediately and begin constructing these harbours. But before a single brick was laid, a bitter territorial dispute threatened to tear the whole project apart before it even started. The Navy wanted to run everything, insisting that anything that floated was their domain. The Army disagreed sharply, arguing this was fundamentally an engineering job that belonged under Army control. The 2 sides clashed repeatedly for months, filling meeting rooms with heated arguments and grinding critical decisions to a halt. It wasn't until December 15, 1943, that the top military brass finally stepped in and forced a compromise. The Navy would take charge of the old ships they planned to sink as breakwaters, the floating outer defences called bombardons, and would oversee all the assembly work happening along England's southern coast. They'd also map out the French coast, mark safe channels for navigation, and pull all the pieces across the English Channel with their tugboats. The Army, meanwhile, would build the enormous concrete structures they called Phoenix, construct the floating roadways nicknamed Whale, and position anti-aircraft guns for protection. Once everything reached France, the Army would sink those concrete boxes into place and assemble the complete working harbour. With this division finally settled, actual construction could finally begin. The scope of what they were attempting dwarfed anything Britain had ever undertaken. Starting in summer 1943, construction ramped up dramatically, pulling in as many as 45,000 workers spread across dozens of different sites at once. The concrete structures alone were engineering feats that seemed almost impossible. The biggest Phoenix units stretched 200 feet long and rose 60 feet high, each one weighing over 6,000 tons when finished. They needed 213 of these concrete boxes total, which meant pouring more than 1 million tons of concrete and using 70,000 tons of reinforcing steel. They carved enormous excavation pits from the Thames and Medway riverbanks to create the dry dock areas where these massive Phoenix units could be constructed. Building each caisson demanded a level of precision that felt almost unreasonable given how fast they needed to move. Every Phoenix structure was basically a giant concrete box that stayed airtight except for special valves that could be opened to flood it and sink it to the ocean floor in exactly the right spots. The walls had to be thick enough to survive violent ocean storms, but light enough that the structure could actually float while being towed. The steel reinforcement bars had to be positioned with mathematical accuracy to keep the structure from failing structurally. Concrete had to be mixed carefully, poured, and allowed to set under controlled conditions, all while the country faced desperate shortages of cement and steel. Construction companies throughout Britain received orders to build individual sections. Warts Construction, Balfour Beatty, Henry Boot, Bovis and Company, Costain, John Lying and Son, Peter Lind and Company, Sir Robert McAlpine, Mowlem, Nuttall and Taylor Woodrow all got pieces of the work. These firms built in almost total darkness about the real purpose. The demands of secrecy meant construction workers only knew their specific task, nothing about what the final goal was. Arthur Warts, the managing director of Warts Construction, remembered those days vividly when he was interviewed in 1970, decades later. His workers constructed massive concrete pontoons following exact specifications handed down by government engineers. "We hadn't any idea what these things were meant for," he explained. The rumor floating around the work sites suggested they were somehow connected to housing construction after the war ended. When a high-ranking officer from Whitehall toured the construction yards and saw the confusion on everyone's faces, he stepped in to reassure them. He told them their work was absolutely vital to winning the war. Only after D-Day did the truth finally come out. They'd been building pieces of artificial harbors the whole time. The floating roadways posed equally challenging problems. Alan Beckett's design featured steel bridge sections 80 feet in length, sitting on top of floating platforms made from either steel or concrete, called beetles. These bridges needed to be flexible enough to handle tidal swings of up to 20 feet, yet sturdy enough to carry fully loaded military trucks. The answer involved a specially engineered joint system that twisted and turned with flexibility, allowing each span to move independently while keeping the road surface itself continuous and safe. Engineers would manufacture 16 kilometers of these whale roadways. Every single section had to be engineered precisely so it would connect smoothly with the next piece. The docking areas where ships would actually tie up received the codename Spud. Each one consisted of a massive floating platform with 4 legs that extended down to touch the seafloor, while the platform itself bobbed up and down with the tide. Hydraulic equipment allowed operators to extend or shorten those legs as tidal conditions changed, keeping the dock level constant regardless of water level. The engineering precision required was extraordinary. Tolerances measured in fractions of an inch on structures that weighed hundreds of tons. Testing became absolutely essential. Scotland's harbour at Garliston in Wigtown Bay provided conditions similar to the Normandy beaches they'd be facing. The location was flat, sandy, isolated, and didn't have many people living nearby. This made it perfect for testing everything at full scale. Security forces cordoned off the entire region. People living there were evacuated using wartime emergency powers. The entire area from Garliston all the way to the Isle of Withorn became forbidden territory. Military engineers and support crews set up a camp at Cairnhead to house hundreds of workers who would test and refine the Mulberry parts. What those tests uncovered was sobering. Early designs for the floating roadways collapsed and broke apart when a 7-ton truck drove across them in realistic wave conditions. Some experimental flexible roadway designs washed away completely during a severe storm that hit the testing site. The legs supporting bridge spans sank into the sandy bottom, causing the spans themselves to fail structurally. Only Beckett's whale design survived that storm without damage, which settled the question. His design would be used for the final harbours. The massive floating breakwaters, called bombardons, built from steel and rubberized canvas, required major changes after test failures showed serious problems. The original design connected individual bombardon units with hemp rope. The tests revealed a fatal flaw. Those ropes snapped under storm conditions, allowing the huge structures to drift into the protected inner harbor where they'd caused tremendous damage. After repeated failures, engineers replaced all the rope connections with heavy steel cables and added backup safety systems. Secrecy surrounding the project became almost paranoid in its intensity. They chose the codename Mulberry specifically because it told you absolutely nothing about what the project actually was. It was simply the next name on a list of randomly selected codenames in military use. All paperwork and communications used only the word Mulberry, never mentioning artificial harbors or floating ports by name. Construction site workers signed secrecy agreements. Taking photographs of any components was strictly forbidden. Spy services stationed people in pubs near the workyards, listening carefully for anyone talking carelessly about what they were building. German reconnaissance aircraft created constant danger. Luftwaffe pilots regularly flew over southern England, looking for any signs of invasion preparations. The Phoenix caissons were simply too enormous to hide once construction began in earnest. The cover story put out was that these were experimental barriers designed to stop enemy submarines in the English Channel. German intelligence appeared to accept this explanation without question, so they made no special plans to defend against artificial harbors. Then came a security scare that nearly revealed everything. In May 1944, just weeks before D-Day, the crossword puzzle in the Daily Telegraph began including clues that pointed directly to Operation Overlord secrets. Day after day, the solutions spelled out Utah, Omaha, Juneau, Sword, and Gold, the 5 invasion beaches, and most worryingly, the word Mulberry itself. MI5 launched an urgent investigation into Leonard Dorr, the schoolmaster who created the telegraph crossword. Through intense questioning, investigators learned that Dorr frequently asked students for interesting words to use in his puzzles. Many of those students lived near American military bases where overlord planning was happening. The words had entered Dorr's vocabulary naturally through casual remarks students had overheard and innocently repeated. MI5 eventually concluded that these classified operation names appearing in the crossword was genuinely coincidence, though an unsettling one. They continued investigating even after D-Day to make absolutely certain Dorr wasn't a German spy using an incredibly subtle code system. By June 1944, the artificial harbors existed in pieces. Thousands of individual components scattered across southern England, waiting to be assembled. The challenge of moving them to collection points, then towing them across the Channel, then positioning them off the Normandy coast seemed almost impossibly complex. 2 complete harbor systems had been finished. Mulberry A would serve American troops landing at Omaha Beach near Saint-Laurent-sur-Mer. Mulberry B, also called Port Winston to honor Churchill, would support British and Canadian forces at Gold Beach near Arromanches. Each harbor needed roughly 600,000 tons of concrete and prefabricated steel parts. The complete list of components included 213 Phoenix caissons of various sizes, 10 miles of whale floating roadways, 33 pierheads, 70 used merchant ships designated for sinking as extra breakwaters in areas called gooseberries, and 24 enormous bombardon floating breakwaters for outer protection. Towing this artificial fleet required 150 ocean-going tugs that had been specially modified for hauling heavy loads across long distances. These tugs carried large letters M painted boldly on their smokestacks. The crews took enormous pride in their assignment, knowing they were participating in history's most audacious engineering undertaking. The towing operations themselves posed staggering difficulties. Phoenix caissons could only be pulled at speeds under 4 knots, or the concrete structures risked damage. Hauling them from English assembly yards to the Normandy coast would take roughly 2 days under perfect conditions. Weather forecasting became absolutely critical. Rough water could damage the delicate parts or snap the tow cables. The tugs had to steer through waters filled with mines while holding tight formation in massive convoys. Royal Navy mine-clearing vessels worked ahead of the Mulberry convoys, sweeping channels through enemy minefields that had been laid months before. June 4, 1944, brought the first orders to move. Mulberry Harbour sections started being towed behind tugs and positioned in mid-channel, standing by for the invasion scheduled to begin June 5th. Then the weather changed everything. A powerful storm system moved into the channel, forcing postponement. The Mulberry components pitched and rolled in heavy seas for a full day, while Eisenhower wrestled with the decision whether to wait or push forward. When Eisenhower finally ordered the invasion to proceed on June 6th, the artificial harbour components were already out at sea. In the pre-dawn darkness of D-Day, while Allied soldiers fought their way ashore under withering enemy fire, the first pieces of the Mulberry harbours were being towed into their final positions. Everything proceeded with remarkable coordination, even amid the overwhelming chaos of the largest amphibious invasion ever attempted. On June 7th, the first Phoenix caissons were moved into position roughly a mile offshore from both Omaha and Gold Beaches. Powerful harbour tugs maneuvered these enormous concrete structures with surprising delicacy, carefully positioning them at precise spots marked by buoys that Royal Navy survey teams had placed days earlier. The flooding process for the Phoenix caissons showed how brilliant their engineering truly was. Each caisson contained multiple separate chambers with their own flood valves. Engineers could flood individual chambers to fine-tune positioning and rotation before lowering the entire structure to rest on the ocean floor. Hours of meticulous work went into positioning each caisson, but the payoff was worth the effort. As the Phoenix breakwater grew, it created calm water where vessels could anchor securely. At the same time, 70 old merchant ships moved into place for sinking. These vessels, code-named corncobs, and together called the Gooseberry Breakwaters, had been gathered at Oban on Scotland's western coast months prior. Stripped of anything valuable, loaded with ballast to control how they'd sink, and rigged with explosive charges, they made their final journeys under their own power. When they reached their assigned positions near the invasion beaches, the crews opened the flood seacocks, triggered the explosive charges, and abandoned ship. The vessels went down to the bottom in carefully calculated positions, forming an outer defense against Atlantic swells. At Utah Beach, 10 ships including the Benjamin Conti, David O'Shea, George S. Watson, and Victory Sword went to the bottom. At Omaha Beach, another group of corncobs established the outer line of Mulberry A. The scuttling went so smoothly that most vessels settled within 50 feet of where they were supposed to be. A stunning accomplishment, considering the difficulty of deliberately sinking a ship in exactly the right spot. The whale roadways followed, long chains of connected platforms and bridge spans that snaked their way across the channel, pulled by specialized tugboats. Once they arrived at their destination, Royal Engineers fastened them to the spud pierheads and extended them toward shore. The flexible joints that Beckett had engineered proved their value as the roadways rose and fell with the waves while staying structurally sound. By June 13th, Mulberry B at Arromanches had developed enough to function as two crescent-shaped harbours, capable of handling up to 75 larger ships and numerous smaller vessels at the same time. The speed at which everything came together amazed even the engineers who had planned it all. Only 7 days after D-Day, both artificial harbours were already handling cargo deliveries. The first supply ships pulling up to the Mulberry facilities found themselves in an extraordinary situation, tying up at piers that simply hadn't existed 10 days before. In harbours constructed from materials that had been spread across England just 2 weeks earlier. Captains who'd spent years working traditional harbours stood amazed at what human ingenuity could accomplish. Captain James Morrison, commanding the Liberty ship, Robert E. Perry wrote in his ship's log his amazement at what he found. He noted that where the nautical charts showed only open beach, an entire harbour system awaited him, complete with floating piers, protective breakwaters, and navigation markers. His ship docked at Pier 7 of the Arromanches harbour and unloaded 400 tons of ammunition, 200 tons of food supplies, and 150 vehicles in just 8 hours. The entire installation rises and falls with the tide, moving 15 feet between high and low water, yet it continues operating flawlessly throughout. The engineering required for all of this is simply beyond my comprehension, he recorded. Then catastrophe hit. On June 19, 1944, the worst June storm in 40 years roared across the English Channel. For 3 consecutive days, winds from the northeast, gusting between 46 and 48 miles per hour, battered the Normandy coast relentlessly. Waves towering 8 feet high smashed relentlessly against the artificial harbours. The bombardons positioned along the outer breakwaters, designed to withstand this kind of abuse, began giving way under the onslaught. Some crumbled into pieces beneath the relentless pounding. Others tore loose from their moorings and drifted into the inner waters, colliding with Phoenix caissons and whale roadways with devastating force. At Omaha Beach, Mulberry A took a catastrophic beating. The harbor wasn't finished when the storm struck with full fury. Vital reinforcement work and anchor systems remained incomplete. Wave after wave hammered the Phoenix caissons until they fractured. Whale roadways broke free and washed ashore in tangled confusion. When the storm finally subsided on June 22nd, Mulberry A was finished. The Americans made their decision to scrap it without hesitation. Investigation revealed that fixing the harbor would consume more time than constructing it from scratch. First, they'd need to clear away the wreckage and debris. So they salvaged every workable component and shipped them to strengthen Mulberry B at Arromanches. The British harbor, blessed with natural protection from the geography of Gold Beach and more substantially built before the tempest hit, endured the battering and stayed in working order. Workers incorporated the salvaged American equipment into Mulberry B. They pumped sand into the Phoenix caissons to anchor them more securely, a decision that clearly extended how long the British port could function. The storm vindicated the Mulberry concept, even as it devastated one installation. At Omaha Beach, the gooseberry breakwater fashioned from scuttled ships held steady throughout. Vessels sheltering behind these block ships weathered the tempest with relatively little harm. Had that simple protection not existed, the June storm would have scattered the entire invasion fleet and potentially ruined everything. Lieutenant Colonel George Shattuck, commanding 20 Port Group Royal Engineers who ran Mulberry B, documented his thoughts in his official report afterward. The storm from June 19 through 22 pushed our harbor far beyond what it was engineered to handle. That any of it survived speaks volumes about the quality of our engineering and the wisdom of the people who planned this. The bombardons that failed nonetheless protected the invasion fleet by absorbing punishment that would have destroyed everything in open water. Even in defeat, the Mulberry concept proved its worth. Losing Mulberry A forced the Americans to land supplies directly onto the beach, a method they perfected far better than anyone expected. By early July, Omaha Beach was receiving 12,000 tons daily without any proper harbor, astonishing absolutely everyone, even the architects who conceived it. Yet this accomplishment hinged entirely on the gooseberry breakwater, itself a Mulberry component. Mulberry B at Arromanches kept operating long after its original purpose ended. The harbor was meant to last just 3 months, long enough to seize and reopen the port of Cherbourg. But Port Winston functioned for 10 months following D-Day. What this single artificial harbor achieved staggers the mind. Port Winston welcomed 2.5 million men, 500,000 vehicles, and 4 million tons of supplies through its gates. When operating at full capacity, the harbor unloaded 7,000 tons of equipment and supplies each day. The port never closed. Ships arrived and departed at all hours, continuously offloading cargo. The whale roadways exceeded all expectations about their durability. Intended to last just 3 months, they bore constant traffic for the entire 10-month period. Heavily laden trucks drove directly from Liberty ships anchored offshore onto French ground, traveling across floating bridges that rose and fell with the tide. After the war, many bridge sections underwent repair and reconstruction, eventually replacing destroyed bridges across France, Belgium, and the Netherlands. Some remain in place today, including a span crossing the Noire-Eau River in Normandy and another bridging the Moselle River between Cattenom and Königsmarck. German leaders' response to the Mulberry Harbor exposed the utter bankruptcy of their military intelligence and strategic vision. German officers had predicated their whole defensive scheme on the conviction that invaders would require a captured port. Rommel had personally strengthened Cherbourg, Le Havre, and comparable harbors based on this premise. He genuinely believed invasion forces couldn't function without them. The Atlantic Wall, bristling with countless mines and thousands of concrete fortifications, was positioned chiefly to defend port facilities. When Allied troops landed on open beaches instead, German intelligence initially dismissed it as nothing more than a limited assault, not a genuine invasion. Only when the scale became obvious did German officers expect the Allies to drive immediately toward Cherbourg. The sudden appearance of artificial harbors off the landing beaches stunned German high command. They possessed absolutely no advance information about the Mulberry undertaking, despite its enormous scope. The very concept defied what German planners thought militarily feasible. Their astonishment and confusion granted the Allies invaluable time to secure the beachhead. Albert Speer, Nazi Germany's Minister of Armaments and War Production, would offer the most powerful assessment of how the Mulberry Harbor changed everything. After Germany's defeat, during interrogation sessions, and subsequently in his written records, Speer contemplated why the Atlantic Wall had crumbled. His observations, originating from someone who directed Nazi atrocities, nonetheless captured the fundamental reason for German collapse. To build our defensive network across 2 years, we expended 17 million cubic meters of concrete and 1.2 million tons of steel. Just weeks after enemy forces reached the beaches, this enormous expenditure became worthless through a concept of remarkable, elegant simplicity. That simple genius was the Mulberry Harbor. Germany had poured resources into fortifying every harbor along the Atlantic coast. The Nazi leadership believed these fortifications rendered invasion impossible without inflicting terrible losses on the Allied side. Instead, the Allies simply bypassed all those fortified ports, bringing constructed harbors with them across the Channel. This transcended mere tactical cunning. It exposed a profound disparity between how the two societies waged war. German commanders remained trapped in 19th century thinking about fortress warfare and holding fixed positions. The Allies broke free from convention, attempting solutions that traditional military wisdom called impossible. This divergence stretched far beyond just the Mulberry installations themselves. Germany built static defensive lines and waited for armored counterattacks, while the Allies engineered specialized vehicles to overcome barriers. Hobart's funnies, a menagerie of modified tanks, included flail tanks for detonating mines, tanks capable of laying bridges across rivers, and amphibious vehicles that could swim ashore, representing this innovative mindset. Germans possessed technical genius, demonstrated by weapons like the V-2 rocket and jet fighters, yet they lacked sufficient manufacturing capacity and strategic adaptability to translate technical breakthroughs into victory. The Allies, particularly Britain and America acting in concert, merged innovation with industrial manufacturing capacity. The Mulberry Harbors illustrated this fusion perfectly. The technical innovations, from the Bechtel flexible roadways to the Phoenix Casson-controlled flooding mechanisms, embodied the latest in design thinking. Still, the project succeeded because British factories could produce these innovations in vast quantities, despite years of relentless warfare. Some 45,000 workers engaged simultaneously in constructing Mulberry components. Commercial enterprises across the nation temporarily abandoned other war production to manufacture parts. Executing such coordination required unprecedented collaboration between multiple government agencies, military branches, and industrial concerns. Consider merely the Phoenix caissons. The coordination challenge bordered on the miraculous. Creating 213 enormous reinforced concrete boxes, each weighing thousands of tons, consumed more concrete than entire nations produced annually. Fresh construction sites had to be excavated beside rivers. Essential materials, cement, steel, aggregate, required allocation despite catastrophic shortages. Transporting everything to assembly yards demanded specialized equipment and meticulous scheduling. Quality assurance had to ensure every single caisson could withstand ocean towing and battering by storms. The actual towing itself stands as its own maritime triumph, moving 600,000 tons of concrete and steel across 30 miles of open channel while keeping everything aligned and synchronized taxed naval resources to their breaking point. Some 150 tugs participated in Operation Mulberry, representing a substantial chunk of Britain's entire tugboat reserve. Many were commercial craft pressed into military service. Their crews received minimal preparation for hauling massive loads through minefields and across waters held by the enemy. Yet the casualty rate during the cross-channel operation remained surprisingly modest. Only a handful of Phoenix caissons were lost during transport, and most damage came from the June storm itself, rather than the actual crossing. The human dimension deserves acknowledgement alongside the engineering feats. Colonel V.C. Steer Webster, a Royal Engineer instrumental in conceiving, creating, perfecting, and testing every Mulberry component, left behind extensive records now held at McMaster University in Canada. His personal archives illuminate the enormous strain engineers shouldered as D-Day approached. Entries from Steer Webster's journal spanning March through May 1944 chronicle the frenzied atmosphere. March 15, 1944. Churchill came to observe the Whale roadway trial this morning. He insisted on personally crossing the floating structure to confirm it would bear loaded vehicles. After watching trucks successfully traverse it, he looked directly at me and said, "Steer Webster, if this contraption performs in France half as well as it functions here in England, you and your colleagues will have earned Britain's permanent debt. The burden of what we're attempting grows heavier daily." April 3, 1944. Learned today that a pair of Phoenix caissons developed fissures while being towed through test conditions. Investigation identified faulty steel placement at the fabrication facility. Every comparable unit needs examination now. This setback might delay the entire operation if we cannot correct it in days. Sleep feels like a forgotten luxury. May 20, 1944. Final stages approaching. The sheer magnitude of what we've accomplished leaves me speechless. Had someone presented this proposal 3 years ago, I would have laughed and declared it beyond possibility. Yet here we stand, preparing to make the impossible manifest. May Providence guide us. Royal engineers who managed the harbour operations in Normandy supplied first-hand accounts of this monumental work. Sapper William Hutchinson, working with 20 Port Group, wrote home in July 1944. "We're pulling 18-hour shifts maintaining Port Winston continuously. The harbour functions like some enormous mechanical organism. Each tidal cycle lifts the entire structure 15 feet, then drops it again. We constantly reposition moorings, examine pontoons for damage, fix broken roadway sections, and coordinate ship arrivals at the piers. Enemy guns periodically shell our position from inland. Luftwaffe bombers attack nightly, yet supplies keep flowing without interruption. We unloaded 47 ships today, carrying tanks, ammunition, food, fuel, and medical supplies. Everything soldiers require comes through our harbour." Realizing this entire port sprang into existence just weeks ago, assembled in combat from components shipped across the channel, still strikes me as unreal. Merchant captains bringing supplies into Port Winston marveled at its sophistication. Captain Robert Fraser, commanding the Liberty ship John P. Holland, sent correspondence to his company after completing his third journey to Arromanches. Anticipating the usual procedure for unimproved coastlines, anchoring offshore and transferring cargo via smaller vessels to the beach, instead we received instructions to dock directly at Pier 11 within Port Winston. The complete installation featuring breakwaters, floating piers, and navigational systems appeared as permanent and capable as any harbour I've entered during my entire maritime career. The construction and maintenance of this facility, from conception to installation, the securing of it against channel tides and tempests, plus sustaining it under fire, represents an undertaking future historians will examine for generations. We discharged 500 tons of cargo in just 6 hours before departing to make space for the following vessel. The speed matches what peacetime operations achieve at established civilian ports. The contribution of the Mulberry harbours to the triumph in Normandy cannot be minimized. Without them, the Allies faced 3 catastrophic alternatives. First, accept horrendous casualties assaulting a defended port city like Cherbourg, immediately after landing when strength was lowest and opposition most fierce. Second, rely exclusively on beach supply landings, leaving the invasion fleet exposed to weather capable of obliterating everything, as the June tempest made abundantly clear. Third, postpone invasion indefinitely, searching for alternatives that might never materialize. The Mulberry solution escaped these traps. It supplied harbour facilities equivalent to a major seaport, avoiding both the butcher's bill of assault and the peril of open anchorages. The harbours transported sufficient material to sustain the military build-up during those crucial initial weeks. By June 26th, when American soldiers captured Cherbourg, the acute danger had passed. The Allies had planted their flag and dug in across France. Even after German forces destroyed Cherbourg's installations, rendering the harbour inoperable for considerable time, forward momentum never slowed because Port Winston kept supplies flowing. The consequences rippled across subsequent strategy. The triumph of the Mulberry harbours transformed how the Allies approached amphibious warfare from that moment onward. Future operations no longer required seizing a port facility beforehand. Subsequent landings could occur on any defensible beach, sustained by artificial harbour technology, until genuine ports fell under Allied command. This adaptability handed the Allies decisive benefits when selecting landing zones. Planners could favour beaches with lighter defences rather than those nearest harbours. German commanders, now unable to concentrate forces purely around port installations, faced the nightmare of defending thousands of miles of unfortified coastline where invasion might strike anywhere. The paranoia that gripped German leadership forced them to scatter their military resources across miles of coastline, preventing them from concentrating firepower at the critical moment of invasion. Meanwhile, Allied planners were already thinking far ahead. Engineers began working on proposals to deploy Mulberry technology across the Pacific theater. Teams were sent out to examine potential beaches in Japan, measuring distances, studying terrain, and calculating what construction challenges would need solving. Then came August 1945. The atomic bombs fell on Hiroshima and Nagasaki, and suddenly all those carefully laid plans became irrelevant. Yet the very fact that such planning had progressed so far revealed something profound about how completely the Mulberry concept had been accepted into Allied military strategy. It had become the default solution, not an experiment, but standard procedure. Nothing like this massive engineering undertaking has been attempted in wartime since those pivotal months in 1944. The entire achievement remains singular in military annals, combining technological breakthroughs, industrial production scaled to enormous proportions, absolute security, intricate logistical coordination, and live deployment under enemy bombardment. History offers no parallel. Military strategists today still turn to Mulberry harbours when teaching how to overcome seemingly insurmountable problems through engineering determination and creative thinking. The original installations left physical traces that endure. At Arromanches, sections of the Mulberry Bee harbour remain visible along the shore. The Phoenix caissons emerge from the water when tides recede, their massive forms still delineating where the outer breakwaters once stood. Fishermen working these waters have repurposed them entirely. The concrete structures serve as reliable navigation markers. Tourists walking the D-Day beaches can see firsthand what those Allied engineers constructed, tangible evidence of what was accomplished during that remarkable period. Several of these imposing structures are scattered along the British coastline as well, standing as reminders of both the engineering triumphs and the costly failures that preceded success. One particular caisson at Pagham Harbour in West Sussex tells its own story of failure transformed into history. It was designated as the supporting structure for the artificial Mulberry, but sank during the towing operation and could never be refloated. The concrete giant now rests permanently visible at low tide, officially protected as a historic monument. Another massive structure originally intended for the farm Mulberry suffered structural failure during a violent storm the night before the invasion began. That one lies submerged in deeper offshore waters, lost to the sea but not to memory. At Thorpe Bay near Southend-on-Sea, an entirely different caisson experienced problems during its transport. As it was being towed toward the assembly zone, water began pouring through breaches in its hull. Rather than risk losing it entirely to the channel, commanders made the tactical decision to beach it deliberately on a sandbank in the Thames estuary. It too has been granted protected monument status, and determined visitors willing to wade through thick mud at low tide can still examine its construction methods up close. These accidental monuments scattered along two coastlines stand as powerful reminders that the Mulberry project carried genuine dangers, that not every component functioned as the designers had envisioned, and that getting these enormous structures to France intact proved far from guaranteed. The June storm tested the system mercilessly, destroying one complete harbour outright and inflicting serious damage on the other. Yet the endeavour ultimately succeeded because British and American engineers possessed the foresight to build redundancy into every critical system. They had developed multiple solutions for problems that threatened the entire operation. When initial designs proved inadequate under real-world conditions, teams adapted with remarkable speed. The long-range consequences of the Mulberry Harbour Initiative extend far beyond military applications into the realm of civil engineering. Innovations born from wartime necessity found productive peacetime uses. The floating bridge concepts that Beckett had pioneered advanced dramatically as engineers refined the principles. Post-war harbour construction worldwide benefited from hard-won knowledge about breakwater design and accommodating tidal forces. The concrete production and curing methods perfected under wartime urgency to produce those massive Phoenix caissons entered commercial construction practices everywhere, improving how buildings and infrastructure were constructed. Perhaps most significantly, the Mulberry project demonstrated a transformative truth: that massive infrastructure works could be compressed from years into mere months, when genuine need demanded such compression. The organizational skills and project management techniques forged during Mulberry construction spread globally into peacetime building programs. The workers who had constructed these artificial harbors dispersed after war's end into commercial construction firms, carrying with them irreplaceable experience in managing enormous undertakings under relentless pressure and impossible constraints. Recognition for these architects of impossibility came slowly. Wartime secrecy classifications kept technical particulars locked away for years after 1945. The engineers themselves, trained to modesty and skeptical of publicity, rarely pushed their own achievements into public view. Stuart Mackay's personal papers remained private possessions until his family donated them to McMaster University in 1976. Hugh Ironside Hughes never received formal honours during his lifetime, though his fundamental contributions to harbour design proved absolutely essential. Alan Beckett pursued his engineering career in relative obscurity, despite the crucial role his Whale roadway system had played in Mulberry's functionality. Decades had to pass before historians began to comprehend fully the magnitude of what these individuals and their teams had accomplished. The Institution of Civil Engineers finally accorded Mulberry Harbour's appropriate recognition by including the project among 200 celebrated achievements during the institution's bicentennial in 2018. Academic research eventually examined both technical innovations and organizational frameworks that made success possible. Documentary productions exposed the story to wider audiences. Military historians increasingly acknowledged that D-Day's triumph depended equally on engineering genius and military courage. The philosophical gulf between how Germany and the Allies approached the invasion problem crystallized dramatically through the Mulberry Harbours. Germany opted for the straightforward solution: fortify the ports so overwhelmingly that capturing them becomes an unthinkable objective. The Atlantic Wall, constructed from staggering quantities of concrete and elaborate defensive emplacements, represented conventional military reasoning, pursued with characteristic German precision and resources. The Allies selected the counterintuitive approach: render existing ports irrelevant by fabricating new ones wherever needed. This strategy demanded faith that impossibility could transform into possibility through engineering prowess and industrial might. It required leaders courageous enough to authorize enormous expenditures, backing an untested concept. It demanded engineers prepared to attempt what their educational backgrounds insisted couldn't be accomplished. It relied on construction workers laboring without full comprehension, building components for purposes they couldn't entirely grasp. This divergence in mindset explains Allied victory at a fundamental level. German military thinking emphasized obedience, hierarchy, and reliance on established methods. This approach produced exceptional technical execution, but created brittleness in planning. Whenever Allied actions departed from German expectations, the command framework struggled to recalibrate. American and British military culture prioritized innovation, adaptability, and pragmatic solutions to novel obstacles. This sometimes generated confusion and wasteful effort, but it permitted swift adjustment when standard approaches fell short. Allied planners confronted strategic challenges without conventional answers and pursued unconventional alternatives without hesitation. The Mulberry harbors embodied this cultural opposition perfectly. A German commander facing this challenge would have calculated the forces required to seize an existing major port and accepted the casualties that conquest would demand. An Allied commander authorized the construction of floating cities that bypassed the entire problem through radical reimagining. In 1984, marking 4 decades since D-Day, Mulberry engineers who had survived the intervening years gathered at Arromanches to contemplate their collective achievement. The reunion brought together British and American personnel, military officers and civilian contributors, design architects and construction crews. The Imperial War Museum preserved their recollections, creating a permanent record of their experience. Bruce White, who had directed much of the actual construction work, addressed the assembled group during the dinner. "We were young men," he began, given what seemed an impossible assignment. Build a harbor that could be assembled in mere days. Build it tough enough to withstand Atlantic gales. Build it with capacity exceeding Dover's despite being anchored to sand rather than solid rock. Every principle I'd learned in engineering school insisted this couldn't be done. He paused, letting the weight of that contradiction settle. But we had no alternative. The invasion couldn't proceed without solving these impossible problems. So we stopped asking why it wouldn't work and started asking how to make it work instead. He described the relentless cycle. We tested, encountered failure, adjusted our designs, then tested again. We manufactured at industrial scales that pushed Britain's factories to their absolute limits. We towed massive concrete boxes across treacherous waters in conditions that seemed designed to sink them. His voice carried emotion as he continued. We assembled harbor components while German guns were firing at us. It wasn't perfect. We lost Mulberry A to the June storm. Countless components gave way. Repairs became constant requirements, but it worked sufficiently. Port Winston maintained the supply chain. That harbor purchased the time we desperately needed to take Cherbourg. He looked directly at his audience. That time determined whether we would achieve victory or face defeat. Alan Beckett stepped forward to share his own memories. "I was young lieutenant when they assigned me to solve the floating roadway problem," he began. The requirements seemed contradictory. The roadways had to flex enough to accommodate 15-foot tidal movements. Simultaneously, they had to remain rigid enough to bear the weight of fully loaded lorries. They needed durability to survive months in salt-laden seawater. They had to be straightforward enough to mass-produce rapidly. They had to survive transport across the channel without structural damage. He shook his head slowly. Each requirement individually presented serious engineering obstacles. Combined, they appeared completely unsolvable. I filled weeks with design sketches, constructed scale models, tested them in laboratory tanks. I was stuck. His expression brightened. Then one afternoon, I watched a snake crossing sand. Its body flexed at multiple points while the creature maintained continuous forward motion. That image sparked the insight. The roadway needed identical properties. Each span could remain rigid, but the joints had to permit torsional flexibility. He emphasized the moment. That flexibility principle became the crucial breakthrough. Once we established that concept, the remaining engineering details fell into place logically. Standing now at Arromanches, seeing those whale roadways still functioning 10 months after D-Day, carrying traffic far beyond what we designed them to handle, that accomplishment brings me greater satisfaction than any other engineering contribution I've made across my entire career. An American engineer who had worked on Phoenix caisson construction took his turn. "People rightfully focus on the technical innovations," he said, "but the manufacturing process deserves matching recognition. We constructed 213 massive reinforced concrete structures in 8 months. This was happening while Britain fought for its very survival. Every material was critically scarce: cement, steel, timber, workers, transportation. Everything was claimed by multiple urgent needs. He leaned forward. Yet Mulberry received what it required because Churchill and Eisenhower grasped its strategic significance. The organizational complexity was staggering. Concrete had to be mixed to exacting specifications. Steel fabrication required millimeter-level precision. Caissons were constructed inside specially created dry docks established along riverbanks. Then we flooded those docks, refloated multi-thousand-ton concrete structures, and towed them to assembly points without catastrophic failure. His voice grew more intense. We accomplished this simultaneously at numerous locations while maintaining absolute secrecy. German bombers attacked nightly. From the lowest-ranking laborer to the most senior engineer, everyone recognized they were building something that would alter history's course. A Royal Navy officer who had commanded one of the tugs towing Phoenix caissons shared his perspective. The channel crossing required 2 full days at our maximum safe speed of 4 knots, he explained. My crew towed Phoenix Unit 47, one of the largest caissons, weighing over 6,000 tons. The tow cable was as thick as a man's arm. I watched it strain nearly to breaking point as we moved through mine-cleared channels marked with buoys that German E-boats kept trying to remove. He described the orchestration. Thousands of vessels filled the channel, all heading toward Normandy. Everyone maintained position while avoiding collisions with other tows. When we reached our assigned location off Omaha Beach, we held steady while engineers flooded Phoenix carefully, methodically, taking 6 hours to sink that enormous structure into precise position. Then we cast off and returned to England to retrieve another caisson. My crew completed 4 full round trips in 10 days. We survived on tea and determination, never questioning why our work mattered. The reunion concluded with a pilgrimage to the beaches where Mulberry Bee had once functioned as a bustling artificial port. The participants, now elderly men, walked across sand where harbor components had created temporary shelter. Phoenix caissons visible offshore marked Port Winston's ghostly outline. Several engineers became emotional, remembering fellow workers who hadn't returned from the war, contemplating the extraordinary scale of their 1944 accomplishment. One participant captured the collective sentiment. 40 years ago, we arrived in France as young engineers, facing what seemed impossible. We were instructed to create a harbor where nothing existed before, to shield it from powerful storms using concrete and steel, to support an invasion with facilities that we would assemble in mere days. We feared we would fail, terrified that failure would condemn the men charging these beaches. His voice strengthened. Instead, we succeeded beyond anything we had dared imagine. Port Winston functioned. The supplies reached those who needed them. The invasion held. We contributed to winning the war. Looking back across 4 decades, I experienced tremendous pride in what we achieved. We demonstrated that engineering inventiveness, industrial strength, and sheer determination could solve problems that conventional thinking had dismissed as impossible. He gestured toward the water. The Mulberry harbors answered Hitler's Atlantic Wall. Concrete against concrete, steel against steel, but our concrete floated while their concrete remained fixed. Our steel bent with the tides. Our harbor moved to wherever it was required, rather than standing defenseless waiting for attack. In that adaptability, that innovative thinking, that refusal to accept limitations others imposed, we discovered victory. The German High Command had confidently assumed that ports were absolutely necessary for invasion. They had constructed elaborate fortifications spanning from Norway to Spain, believing that Allied supply demands made capturing a major port inevitable and early. They calculated that defending ports would be sufficient to prevent invasion entirely. They were fundamentally mistaken. The Americans and British had constructed 2 harbors over 8 months within England, transported them across the Channel in 3 days, and assembled them into functioning ports within 2 weeks. The accomplishment contradicted every conventional measure of feasibility. It required engineering innovations that didn't exist when planners began the project. It demanded industrial production that strained Britain's capacity to its absolute breaking point. It needed coordination spanning dozens of government agencies and private companies. It meant moving and assembling harbor components while receiving enemy fire. Yet it succeeded. The Mulberry harbors demonstrate human ingenuity's power. the triumph of innovation over rigid conventional thinking, the victory of flexible problem-solving over doctrine. Confronted with a strategic challenge that seemed to have no solution, Allied leadership refused to accept impossibility. They instead asked how engineering could transform the nature of warfare itself, creating an answer that changed the fundamental rules of amphibious invasion. The artificial harbours of Normandy represent the ultimate manifestation of the arsenal of democracy. The fusion of engineering, breakthrough, and industrial might that characterized Allied victory in the Second World War. Beyond the specific battles fought, beyond individual acts of heroism, beyond tactical brilliance displayed, it was this willingness to attempt the seemingly impossible and transform it into concrete reality that ultimately decided the war's outcome. Germany fortified what already existed. The Allies created what was required. In that fundamental difference lay the foundation of D-Day's triumph and the Third Reich's ultimate destruction.